Welcome to DIY Life Hacks. As part of an extension of this video series, I'm also going to be talking about some pure science topics for fun and also to encourage citizen science. My dog's down there and he's grinning at me. The first topic comes from my best friend who wanted to know more about the Higgs boson. I've found that it's kind of this buzzword, you know, it's like the God particle and this really big hullabaloo, but the actual understanding is totally lost. So anyway, the Higgs boson, what is it? What does it do? Why is it really important? Well, first of all, it's important to know that there are four fundamental forces: gravity, and then there's the electromagnetic force, the strong nuclear force, and the weak nuclear force. So what's really interesting to me is kind of the history of how these four forces came about. For a long time, scientists and the public thought that electricity and magnetism were two separate forces. But Michael Faraday showed that a moving electric field generates a magnetic field, and a moving magnetic field generates an electric field, which is super crazy because that means that they're the same force. So Faraday showed this experimentally, and then Maxwell actually put it into mathematical form. So this kind of got physicists thinking, well, I wonder if that means that there's, one grand unified theory of the universe, or GUT for short. To start merging some of these forces together, you need a mechanism to account for the fact that the weak force has massive force transmitters, and the electromagnetic force is carried by photons, which are totally massless. So that's like a huge, weird discrepancy. And so the Higgs mechanism was proposed in the 1960s by Peter Higgs and a few other physicists at pretty much the same time, but Higgs was the lucky one to get his name on it, maybe because he was an old white dude, although they all probably were. Anyway, the Higgs mechanism is what is responsible for giving mass to the weak bosons, or the force transmitters of the weak nuclear force, and it doesn't interact at all with photons. So that's exactly what they wanted. And that basically means that the weak nuclear force and the electromagnetic force are, pow, the same force. And so with some fancy math you can show this. It's called gauge symmetry. If you really want to look it up, Wikipedia has a great article on it. Using gauge symmetry you can describe the electroweak force. The very basic idea is that you can introduce stuff as long as you keep the equation consistent. So they found that if you add a field that's a scalar field, all of a sudden you can rewrite it so that this new field couples to the weak bosons and it does not couple to the photon. And so it's like, oh my gosh, what is this field? All of a sudden we did something kind of hand-wavy and magical, but it actually is there's something there. And so since the 1960s, they've been looking for the Higgs boson, which is the smallest possible excitation of the Higgs field, or the smallest particle to come out of the Higgs field. The LHC found what they say is the Higgs boson. And that is so awesome, because that means that the standard model is it's basically pieced together at this point. So it's like, okay, what can we expect next? If you have any questions, please feel free to ask them, and I'm happy to answer them, and if I can't answer them, I'll direct you to Wikipedia probably. But yes, thank you for watching. Yay, science! And yeah, please subscribe.